This is a shot. Remember, when we have a trinomial with the highest exponent or degree being 2, and the leading coefficient is 1, so there is no number that we can see in front of the x squared, then we can use this method where we take our constant and look for ways to multiply to 60. Woo. And which pair of numbers multiply to 60, there's not a ton, also add to 16. So maybe you're thinking, when you look at your factors of 60, and sometimes it helps to actually list them out, or at least look at the list if you're not sure. 6 and 10 are the one pair of numbers that multiply to 60 and add to 16. So then we put those pairs, once we have our left, and I'm going to call them just a left number and a right number, left number, right number, not hashtag. Then we put them after our x's. And yes, you could put the right number in place of the left number. It won't matter because multiplication is commutative. Oops, but don't put the left number in place of both. And whatever sign, if this number is positive, it would be a plus sign. If the number is negative, it's a minus sign. So to factor this thing, it's just x plus 6 times x plus 10. That's it. If you were to FOIL this or multiply this back together, if this was the problem, hey, multiply this together in factored form, and this is your answer in standard form. Let's try number 3. So now we're looking for numbers that multiply to -8 and add to 7. Now I'm going to make the list of numbers that multiply to 8. 1 and 8, 2 and 4. Well, we could make the first numbers negative or the second numbers negative. One of the two numbers has to be negative to multiply to a -8. So which pair now pretend it's not a multiplication problem, pretend it's an addition problem. Which ones add to +7? Right there. These two numbers multiply to -8 and add to +7. So x minus 1, x plus 8. Rolling along. Numbers that multiply to -21 and add to -4. So your factors of 21 is 1 and 21 and 3 and 7. Here's the trick. Because they add to a negative number, that means the bigger number, think of that as you owing me $4. And one of the numbers is positive, one of the numbers you get to keep, and one of the numbers you owe me. Since in the end, you owe me $4, the bigger number has to be negative. So when I take 3 plus -7, I get -4. If that didn't make any sense, just write out both options. Make a list for the left number negative, and then make a list with just the right numbers being negative. This is the combination though. 3, -7. So in our factored form, it's n plus 3, n minus 7. Ooh, number 7 looks like fun. Numbers that multiply to +12, hey, that's easy. 1 and 12, 2 and 6, 3 and 4. But they add to a -8. Holy schmoly. Well, remember, 2 negatives multiply to a positive. Yes. And 2 negatives add up to an even bigger negative. So I just took that factor list that you see for the factors of 12 and made both numbers negative. These two right here still multiply to a +12, but they add now to a -8. So x minus 2, x minus 6. -20, -1. 120, 210, 4, 5. Now it's a -20, so one of these pairs need to be negative. And I notice, so that means in one hand you have some money, in one hand you have a IOU. And the difference is only $1. So let's see here. I think that's this pair. And then the 5 would be negative. 4 and negative 5. X plus 4. Oops. Let's use the right variable. V plus 4. V minus 5. Ooh, the factors of 70. That'll be fun. Well, I'm going to skip it. I'll let you try that one. I'm going to skip down to... Okay, I'll do it. 70 and negative 17. So both numbers are negative. 4, 5, 6, 7, 8, 9, 10. I think this is our only combinations. Both numbers are negative. So which pairs actually add to negative 17? Right there. Negative 7, negative 10. N minus 7, N minus 10. If you foiled that back together and multiplied it back together, oops, let's do 10, negative 10. Multiplied it back together, you would get this thing in standard form once you simplified it. So here's a big deal. Number 13 has a leading coefficient, and we talked about how this method that we're using only works when your leading coefficient is 1. So we can't do this problem the way we've been doing it. Tuesday, we'll learn how to factor something that does have a leading coefficient. But today's not Tuesday, today is Monday, at least the year that we did this. The first step when you look at your factoring chart is to always look for a GCF. Now, and I haven't been asking you to do that on these other ones, but if we think about it, this term never has a variable, and this term has never had a number coefficient bigger than 1. So we haven't been able to. Here we can. So we're going to factor out a 3, which now makes this x squared plus 9x plus 18. I'll get there in a second. X, I meant to change colors. That's why. It's funny, I was changing colors. That's why I wasn't thinking real clearly there. And then I forgot to change colors. So plus 9x plus, 18. How I kind of think of that is 3 times 8 is 24. It ends with a 4. So it's likely there. And then 24 plus 30 is, anyway. So, folks, now I wrote that in a different color because what we have in red is a trinomial with a leading coefficient of 1 and a degree of 2. So we're going to actually factor what's in red. Numbers that multiply to 18 and add to 9. So that's 3 and 6. So to factor what's in red, we have x plus 3, just like we've been doing before, x plus 6. But that 3 comes down, out in front. Same with number 15. We can factor out a 3. We get 3m squared plus 6m minus 27. So now we're looking for numbers that, I'm going to change this color, numbers that multiply to negative 27 and add to 6. So this is a negative 27. One of the numbers needs to be negative. But when we add them, it results in a positive number. So I'm going to make the negative go with the smaller number. So negative 3, positive 9. Yep. So m minus 3, m plus 9, that coefficient, or that GCF, of 3, which is like a coefficient now because it's a multiplier in front, goes out in front. So here's our final answer. Last one. We can, oh boy, we get a trinomial. 3 terms, highest degree is 2. That's awesome, except for my leading coefficient's not 1. So can I factor anything out? I can factor a 5 out. So 5, in parentheses, b squared minus 6b minus 35. So what are some numbers that multiply to negative 35 that add to negative 6? Is it quiet in here? Because I'm thinking of all the factors of 35, and I... 1, 2, 3, 4, 5, 7. Did I? Oh, last example, Friday evening. Mr. P's tired. Y'all see Mr. P's mistake? Divide by 5, divide by 5, divide by 5. We're not supposed to be multiplying to 35. We're supposed to be multiplying to -7. Boom. -7, -6. By the way, folks, sometimes there is no answer. You can't solve the diamond problem. It means it's not factorable. But I know Mr. P made this. He knows that they're all factorable. So -7, +1 works here. So b minus 7, b plus 1. Put out the 5. We're just starting this journey, so try not to wreck your confidence and give you ones that aren't factorable. It's kind of mean at this point, but I'll get there soon. Mwah.